Let's talk about expected value. First off, there's a couple of situations with expected value, and one of them is if it costs money to participate. So in this example, we're talking about a company and the expected value of an insurance policy. So it costs money to participate. There are two distinct approaches. One is the way that most books and YouTube videos, etc., talk about, and I'll talk about that with method one. And the other is a way that I kind of stumbled across as I was trying to remember how to do this one year. And I think it's a lot easier when it works, which is when it costs money to participate. First, the book's approach. We have to decide what the events are. So winning and losing are the events for this situation. So event one, the company winning, which would be no accident, they just get the premium. Event two would be the company losing, which would be an accident where they have to give a payout. So we need to discuss the value of event one, and to the company, the value of event one is positive 120. They make $120 in the event that there's no accident. They get to keep the entire annual premium. The value of event two, however, is not the full $3,500. It's negative. They're losing money in this event. So it is minus 3,500 plus the 120 that they can use to offset, giving us negative 3,380. That's the value to the company if there's an accident. Average value, because this is the average insurance payout. Okay, now the probability of event one. What's the probability that there's no accident? And what's the probability that there is an accident? There's the probability that there is an accident is given in the problem, 1.4%. And so that would be 1.4 over 100, 0.014. And then the probability that there's no accident is the remaining probability, which we can get by subtracting from 1, and we get 0.986. Okay, so the expected value is therefore, by the formula, the value of event 1 times the probability of event 1 plus the value of event 2 times the probability of event 2. And if there's 3 and 4 and 5 events, like playing certain games at casinos, then you just continue this process, this same pattern. But this is all we have. The value of event 1, 120. The probability of event 1, 0.986, plus the value of event 2 is negative 3,380, and the probability of event 2 is 0.014. So let's go to a calculator and see what we get. So you have 120 times 0.986 plus negative 3,380 times 0.014. Okay. $71. This is the expected value to the insurance company every time someone buys their $120 annual premium. So clearly they're not expecting to keep all of that $120 because people get in accidents. But overall, if they sold a million of these, they'd expect to earn $71 off of each one. Okay, pretty straightforward, but there's a little bit of arithmetic involved. We do have to do how much the payout is and adjust that with how much the insurance premium was, and we have to do the probability of an accident and adjust that for the probability of no accident. Now let me show you the other approach that I like to use. The events are slightly different. Play and result. So event 1 is the company playing the game, which is they sell a premium. So they get started by selling a premium. And the event that's the scary event for them is if there is an accident. So notice how much is similar and how much is different. The value of event 1 is $120. They get $120. The value of event 2, if there's an accident, is minus $3,500. The probability of event 1 is 100%. Guaranteed they sell the insurance. And the probability of event 2 is 0.014. It's the same as on the left. Okay, so the expected value would be the value of event 1 times the probability of event 1 plus the value of event 2 times the probability of event 2. And it seems so simple, but let's make sure it works. So we have 120 times 1 plus negative 3,500 times 0.014, 71. So the way this is different is we are guaranteeing that we get to keep the $120. Guaranteed that we get to keep that money. Not that we get to keep that money most of the time because we're going to use some of that money to help with the payoff. No, let's just bank on it. And then we have to pay the entire payout every time there's an accident. It simplifies the numbers. We end up using only what's given, and we don't have to do any arithmetic. So I appreciate that about this method. So now it's your turn. If I can get my mouse, there we go. So go ahead and pause the video as you work on this problem. So one way or the other, you lose $16.89 expected for buying a ticket in this raffle. All right, I hope this helps.